Tomorrow you will have a test on what we have done so far in Chapter 3. So that covers sections 1, 2, and 3, which we did from the textbook, and then the proof worksheets that we did, A, C, and D. So as we went over the homework from C and D, we talked about proofs there. We'll talk about proofs a little bit more when we get to the end of our review as well. There will be some proofs on the test, but the test is not going to be entirely proofs. So other things you should be prepared for. Definitions, okay? As usual, your definitions will need to be written with words, not just drawing pictures. The definition of parallel lines is two parts. They are lines that are coplanar and do not intersect. And it's important that we say both of those parts to get full credit because our next word, skew lines, is similar in that skew lines don't intersect, but here they are non-coplanar. So we have to give that distinction. Okay? So parallel lines are coplanar and do not intersect. Skew lines are non-coplanar and don't intersect. Okay, parallel, coplanar, don't intersect. Skew, non-coplanar, don't intersect. Yes, these definitions, you can write them out if you want as we go through them, but if you don't have time to get them written out, they are in your notes on the very first page of the packet. They're also in the textbook in section 3.1. Parallel planes don't intersect.
Did you say skew lines don't intersect or they do?
Skew lines do not intersect. Parallel planes don't intersect. A parallel line and a plane don't intersect. Those don't get any more specific than that. With parallel and skew, we have to say whether or not they are coplanar. Once we start talking about planes, then we can't really talk about coplanar anymore. The last possible word to define is going to be transversal. Again, the definition for transversal is in your packet and in your textbook. But a transversal is a line that cuts across two or more coplanar lines in different points. Okay? You can think about kind of our classic picture of parallel there and what that transversal is doing. It's cutting across lines in different points, and all of those lines are drawn on our paper, so all of those lines are coplanar. Questions on any of these terms?
Those are all.
Those are the only possibilities of words that I will ask you to write out a definition for. Just those 5 for writing definitions. You need to know the 5 ways to prove that lines are parallel. They are on your flow chart in the left-hand column, or they are in your 3.3 notes. They are listed out. You should be able to create this list. For at least 2, maybe 3 tests so far this year, I have told you that you would need to create a list of something, and there's still some people that are leaving those lists blank, which is telling me that you're either not hearing me or just choosing to not believe me or something. I don't know why, but I'm telling you, you will need to write this list of 5 things. So put them on flashcards. Do what you need to do. There are 5 ways to prove that lines are parallel. Corresponding angles could be congruent.
It's all written down in that packet, right?
Yep, it's all in your packet already. AIAs are congruent. SSIAs are supplementary. They could be parallel to the same line, or they could be perpendicular to the same line. Those are the 5 things that are in the left-hand column of that flow chart, or they are also listed as 1, 2, 3, 4, 5 in section 3.3 notes.
You just write like CA congruent?
Yes.
AA congruent?
Yep, you can abbreviate as long as I understand your abbreviation. So if you're using the same ones that I do, that's fine, or as long as your abbreviation is clear about what it's supposed to be, then that's fine. Okay? You will need to list these. I don't know how to say that any more clearly. Okay? There will be true-false questions about types of these special angles and parallel lines. So here are some examples. True or false? If 2 lines are parallel, alternate interior angles are congruent.
True.
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 If 2 lines are parallel, same side interior angles are congruent.
False.
False. Same side interiors are exception. What do we know about same side interiors? They're supplementary. Be careful with that. Students get in the habit of these are congruent, these are congruent, these are congruent, these are congruent. Same side interior are supplementary when we have parallel lines. True or false? Corresponding angles are congruent.
True.
False. If the lines are parallel, actually.
If the lines are parallel. So if I didn't say that, then that's a false statement. Because corresponding angles are not always congruent. Corresponding angles are only congruent in a case where we have parallel lines. Okay, so watch out for that. Okay. You will need to be able to identify the special kinds of angles that we have learned about. So AIAs, an example of AIA would be like 3 and 6. AEA, we didn't actually define that when we first started talking about these, but we did it a couple of days in our proof problems. What would be an example of AEAs?
2 and 7.
2 and 7 or 1 and 8 are both examples of alternate exterior angles. So they're like the interiors, but they're on the outside. So on the outside and on opposite sides. CA, corresponding angles, there's lots of sets of those in here, but 1 and 5 would be one example of those. Corresponding angles should be in the same corner position. So like upper left, lower right, that kind of thing at our intersection. SSIA stands for same side interior. So we're looking at the middle angles on the same side. So like 4 and 6 would be an example of those. Adjacent angles. Our word adjacent is actually a very old word for us. What does adjacent mean? Next to each other. So we want to pick two angles that are next to each other. So like 1 and 2 are next to each other. 1 and 3 are next to each other. 5 and 6 are next to each other. We just want to pick two angles that are next to each other. Vertical angles. Vertical angles is also an older word for us, but important. We've still been using it a lot in our proofs. Vertical angles are diagonally across from each other at one intersection. So like 1 and 4. It doesn't jump down to the other group. They're just diagonally across from each other at one intersection. Like 1 and 4, or 6 and 7. Questions on our special angle pairs? You will need to be able to identify what those are. Given the measure of one angle and the fact that we have parallel lines, you will need to find the measures of other ones. It says it could be numeric or it could be algebraic. So I could say like angle 1 is 120. How big is angle 6? Okay, well 1 and 6 aren't any special kind of pair that we just talked about. So I could maybe figure out something close to it. What could I do from here?
Figure out, like, if 2 is the same as 6, and figure out what 2 is.
Okay, so how would I figure out what 2 is?
180 minus
If
120.
those are adjacent, they should make a straight line with each other, adding up to 180, so 2 must be 60. And then 2 and 6 are the same since they are what kind of angles? Corresponding. Okay? So given how big one angle is, be able to work your way around and figure out how big some other angles are. It could be numeric like that, or it could be algebraic. I could say like angle 3 is 2x plus 1, and angle 6 is 5x minus 2. What do I know about angles 3 and 6? They're congruent. What kind of angles are they? AIA. And so if our lines are parallel, they are congruent or equal. So I can set those expressions equal and solve for x. So I can subtract 2x from both sides. I can add 2. Man, problems I make up never work out this good. And divide by 3, and I get x is 1. These get really ugly answers when I make them up on the spot. So that was purely luck.
Wow.
What would you have if you did 3 and 8?
3 and 8. So that's a little bit trickier of a relationship. Are 3 and 8 going to be the same size?
They're going to be supplementary.
They're going to be supplementary, but how can we tell?
3 and
Because
7.
3 and 5 are so
Okay, 3 and 7 are the same size, and 7 and 8 are supplementary. So 3 and 8 would be supplementary. So we kind of have to work our way through.
How would you solve, like, That was algebraic.
So let's say we do a supplementary, but maybe I'll do a little bit more straightforward of a pair and say something like angle 4 is 7x minus 2 and angle 6 is 2x plus 1. What do we know about 4 and 6? They add up to 180 because they're same side interiors. So then what I would do is take their two amounts, 7x minus 2, and add it to 2x minus 1, which should equal 180. So if there's supplementary angles, we want to add together their expressions to equal 180. So I get 9x minus 3 is 180. Add 3. 9x is 183. Divide by 9, and this doesn't go pretty, so this is more my normal kind of problem. But you just divide that out on your calculator.
20 and 30. Wow.
Couldn't you just do it like that? That's the answer.
Yeah, that's fine to leave your answer like that too. But you can just type in your calculator to get the answer. Right? Questions about that type of problem? Then you will have proofs. There will be 4 of them, and you will have to do all 4. So it won't be like the last one where you have some choices. There will be 4 proofs, and you have to do all 4 proofs. They are going to be like the ones that were on your worksheets A, C, and D. They could be like exactly the same as those, or they could just be very similar to those. Okay? When I write tests, I kind of aim for middle. So don't expect them to all be like the easiest types of proofs, but also don't expect them to be the hardest. Okay? So like number 20 from the homework last night was really hard. Don't expect to see that on your test. Okay? The problems that I try to put on tests are like the middle problems. Okay? A little bit harder than like the first couple problems, but not as hard as the last problems. Okay? Mainly probably 3 to 5 steps. Nobody should leave a proof blank because we all know how to start a proof. How do we start a proof?
Given.
With the given. That gets you 1 point right there. Okay? That's better than nothing. So you write out your given, you write out the word given. We all know where a proof ends. Where does a proof end? With what we're trying to prove. So we can write that out. We don't necessarily know the reason. So if you write out at least those 3 things, the given, the word given, and what you're supposed to prove, that gets you 1.5 points. Okay? We don't always know where a proof ends, but where did a lot of our proofs end? We use a lot of substitutions, we use a lot of transitivities. Okay? So if nothing else, guess something. Don't leave problems blank. If you leave them blank, they're definitely wrong. If you try something, maybe they're still wrong, but maybe there's something right in there and I can give you some points. I want to give you as many points as I can, but I can't give you points if you don't give me anything to work with. Okay? So don't leave it blank. Try something in the hopes that you do something right. Okay? If you are struggling, I will be here after school. I can really stay like as late as I still have students here. Today is the one day that I don't have to go get my kids either from the bus or from a babysitter. So that gives me a lot of flexibility to stay as late as students need help. So I will be around after school. I will be around before school tomorrow. If you need help, please get the help that you need so that you can be successful tomorrow.